Uh, Hi, everybody. Okay, yeah? Can hear me. Okay, I'm Felip Fenollosa. I'm come from the Fundació CIM, from Polytechnical University of Catalonia, and we are the ones who are technologically backing Hospital Sant Joan de Déu in all their developments using 3D printing. Okay, I'm summing up here in this slide all the process that we are using with Sant Joan de Déu. First of all, you can see that we are scanning the information, taking a DICOM in the facilities, Sant Joan de Déu facilities, and then Aleix had told you how we arrive to a CAD file. He has told you that arriving to this CAD file is really hard work that must be improved. Well, we are here. In fact, most of our cost, most of our time is invested in that part, time in the CAD file. Well, then comes the part of 3D printing. It's in that part that I am going to talk. Mr. Lucas, Dr. Lucas and Aleix have told you how the technology is used, what they do, which is useful for, and I am telling you which are the technologies that we are using. After printing, it's the moment with Dr. Lucas, seeing how to improve. If this prototype is useful, if it's necessary another one, what has been happened. And finally, we get into the operation room. We engineers get into the operation room for really take the information of how the prototype is useful. We need to be there in order to see if the next case must be made with another prototype, with another technology. Because what you are going to see is that we use more than one technology. Yep. Well, first step that we do was use the technology of the PolyJet 3D printing with a Connex machine. Okay, a Connex machine is a machine that works with several materials. That was very interesting for us because we need several materials. Dr. Lucas has told you how he needs to resectionate the tumor, how he needs a tumor, a transparent tumor, a translucent tumor, and flexible elastomerical with elastomerical material, how the rest of geometry needs to be rigid. That's not exactly, but was the first step. I'm writing translucent and soft with the guides because their prototypes are not really translucent and the tumor are not really soft. A real tumor is softer than the prototype that we made. So, as Aleix has told, we need to improve the technology. And a second step, we saw that we need more prototype. And we use the technology of SLS technology to do a prototype without the tumor. And that was a very useful prototype. You can see here how that prototype, the second prototype without the tumor, you can see perfectly the vessels. That was a key point because, well, if you see the tumor, but the tumor is hiding all the geometry that you want to respect, and the tumor is not exactly transparent and not exactly accessible, that was not enough. So, combining the object technology, the strategist technology, with the SLS technology, we could make a good rehearsal of this case. And in this case too, we use the FDM technology, fusion filament fabrication technology, to do a very simple prototype, but still useful prototype. You can see here how the base of the prototype was made with plastic filament, and it's in fact the negative, the mold, in order to position the prototype in the same position of the surgery. That was a key point too. So maybe simple technology, but useful technology. And new steps that we are doing. Here in this case, you can see how we are trying to replace the SLS prototype for a FDM prototype. This prototype is made in an open source 3D printer that you can see here in the fair. It's a Sigma machine by BCN 3D Technologies. And you see the price. Aleix closed his intervention with a sentence from mine telling that we need rapid prototyping as radiography. Without lowering the price, without cutting the cost barrier, we can put this technology at the real user level. All that you are seeing here is extreme cases that fully justifies the cost of the technology. Here, for example, you see the BCN 3D Sigma 3D printer with the last case that really replaced the SLS prototype, was replaced for this FDM FFF prototype. And you can see here the bezels perfectly. Okay. Well, I'm finishing my speech. So what we are asking for the industry or ourselves about this healthcare issue and AM additive manufacturing issue? Well, we are asking to cooperate. Okay, we are asking. We are going to have cases and more cases. We need to lower price, and we need to go further in the technology using all the new machines that are appearing. Here are only few of the most representative of the most brilliant machines that we can find in the market, and we need to talk with these industries and trying to see how these cases can be improved using their technology, and helping them to improve and see which new machines can be made in order to be used in medicine, in healthcare. And finally, to force the industry to develop and be cheaper, it's to making the path, walking the path of the open source technology that in Fundació CIM, in the university, we are developing. Here you can see how from a simple machine of 2,000 euros, we could make a prototype for healthcare, and then we are working in new developments for multi-material. That's the key, I think. Multi-material. It's multi-material that Lucas was asking for when doing next cases. So, more or less is that everything that I had to tell you. So that's another sentence from mine, okay? We want to do anything, but anything must be with imagination and technology. Okay, thanks a lot. Okay.